Okay, this week's tutorial is going to be on graphing linear inequalities. Now, before we can actually graph an inequality, we first have to solve for y. And that's what this little caution is here, to get y by itself. And what we're going to do is we're just simply going to use algebraic properties, and as we have before, and we're going to pay attention to that inequality sign. Remember, if we ever multiply or divide by a negative number, that inequality sign is going to change directions. Let's see if that happens in this case. I'm given the problem negative x plus 5y is greater than negative 5. So what are we looking for here? Well, I want to find out which values of x and y could I place inside this expression so that the result, negative x plus 5y, is greater than negative 5. The first thing we did here is we added x to both sides. And again, we want to get y by itself. And currently we have two terms, right? We have negative x, which is one term. We have 5y, which is another term. And if we if we add x to both sides, that will eliminate the first term. And then I could just bring down 5y. 5y is greater than x minus 5. Where did x minus 5 come from? Well, if you go back up here, remember we added x to both sides. The next step is to undo the process on the left, which is 5 times y, and the opposite of multiplication is division. So we divide the left side by 5, and we have to divide the right side by 5. Once we do that, that gives me y is greater than 1/5 x minus 1. And some of you may be saying, okay, where did he get 1/5 x minus 1? Well, if you look at x minus 5 over 5, since we have one denominator here, and we have two terms in the numerator, we can actually break that up into two fractions. In other words, this is the same thing as the first term divided by 5 minus the second term divided by 5. And 5 divided by 5 is 1. So that will leave us with 1/5 x minus 1. Remember, there's an understood 1 here in front of the x. And this was our goal here. We've isolated y. We have y by itself on the left side in this case. And this would read that y is greater than 1/5 x minus 1. So the question is, how do we graph this? We graph it just as if we were graphing a line. What I would do is I would first identify the y-intercept. The y-intercept is going to be that value on the y-axis. And in this case, the y-intercept is -1. And I'll mark that here below with the red dot. And since the slope in this case is positive 1/5, then starting at the red dot, I would go up 1 block and then go over 5 blocks. And that would give me the next point. And as you know, if you have 2 points, you can connect those and you can draw a line. So that's how we would start the graphing process. But if you look at the solution, they do not use a solid line. They use a dashed line. And the reason we use a dashed line is because the expression says that y must be greater than 1/5 x minus 1. In other words, y must be above the line 1/5 x minus 1. It cannot include the line. So if you want the reader to understand very quickly that all points on the line are not solutions, then you make that a dashed line. If this had been, let's say from the very beginning, let's say that this had been greater than or equal to. If that had been greater than or equal to, of course, we would have continued that throughout. And in this case, we would absolutely have a solid line because it includes the line itself and any set of points above the line. And here is another problem, very similar to the one that we just did. We have y is greater than or equal to negative 3x minus 8. This one's not too bad. This one is already in simplest form, so to speak. We have y by itself. Notice that the slope, which is the number here in front of the x, is negative 3. Notice that the y-intercept is negative 8. And if we know the slope and the y-intercept, it's not too bad to graph. So I'm going to go ahead and graph that y-intercept. I'm going to mark that down here in black. There's the y-intercept. Y is negative 8. And notice that the slope is negative 3. In other words, negative 3 over 1, if you want to do the rise over run. In this case, our rise is actually a drop because the numerator has a negative value. So if you were to start anywhere on this line, if you were to go down, say, 3 spaces, 1, 2, 3, and you were to go over 1, you would continue to hit that line. So to draw the next point, if you want to start at the intercept value, I would start at, let me change colors here. I would start at the negative 8. And I would go down 3, 1, 2, 3 over 1. As you can see, if you extend that line, that's what it would look like. Or if you think about it, you might say, well, if you have negative 3 over positive 1, that would give you the slope, which is negative 3. But you could also think of it as 3 over negative 1, because 3 divided by negative 1 is also negative 3. And if you do that, that means you can start at this intercept value, and you can go up 3, 1, 2, 3, and then back 1. And that would give you the second point. And once you have 2 points, you can sketch that line. So why do we have a solid line this time? Well, if you go back to the original expression, any y value would have to be greater than or equal to the line negative 3x minus 8. And since it can equal the line, then that means all points on the line would make that inequality true. And since it's greater than anything above the line, any of these points in this region here, if you were to take any of these points, yeah, even this one, if you were to take 7, negative 5 and plug in 7 for x and negative 5 for y, you would get a true statement. Let's just look at one more example. If you were to choose, say, this point here, where x is negative 1 and y is positive 6. If you plug in 6 for y and you plug in negative 1 for x, you would get a true statement, because if you multiply negative 3 times negative 1, you get positive 3, and then positive 3 minus 8 is negative 5. And 6 is greater than or equal to negative 5. So again, any points in this region, any points on the line, if you plug those in to the original, you will get a true statement. Thank you.